So I made yet another OpenIPC headset. This one is better, smaller and sleeker than my phone goggles. It has two 60Hz 1440 by 1080 displays, an integrated video receiver, individual IPD adjustment, and is mostly made from 3D printed parts. But why did I do this, and what are the next steps? So it's been a while since my last video, where I showed you my heavily modified Beta FPV VR02 headset. For those of you who have not seen this video, I essentially converted these analog FPV goggles to an analog to digital hybrid, where I still have the same analog functionality as before, but when I press this switch, I can use the goggles to receive digital video with the Ruby FPV system. I did it by including a Raspberry Pi Zero 2W and an extra Wi-Fi module. I didn't expect these goggles to be very good, but I am still a bit disappointed with the performance. The main issue is that Raspberry Pi based Ruby receivers can't decode video from OpenIPC cameras smoothly. There is always a small delay at every keyframe, which I found very annoying. Apparently, this is not an issue when using Raspberry Pis on both the drone and the receiver, but I want to have good goggles to use with OpenIPC cameras specifically. So this meant I had to go back to my 3D printed goggles. But I wasn't fully happy with these goggles either, since they are bulky, require a phone, and are based on a Wi-Fi adapter which is considered not very good. So I decided I wanted something new. The most important part of an FPV headset is arguably the display, or like in my case, the displays. Generally, FPV goggles can belong to one of two categories: box goggles and binocular goggles. To make my goggles as small as possible, I wanted to design a binocular configuration, but I didn't want the goggles to be very expensive to build. Most binocular FPV goggles use micro OLED displays, which can be very expensive, especially at the higher resolutions like 1080p. So, to avoid the high costs of micro OLEDs, I chose these 2.9-inch LCD panels made by Sharp. I saw a couple of DIY VR headset projects online which made use of these panels, such as the DIY VR project by CNC Dan, which I highly recommend you check out. These panels are much cheaper, but also bigger than micro OLEDs, which means my goggles are not quite as compact as most binocular goggles. But this was a compromise I was willing to make. As you can probably tell, the body of my goggles is 3D printed. I designed it in FreeCAD, making use of the curves workbench for the outer shape. I wanted the goggles to be as small as possible with the displays I used, while also having a smooth and appealing shape. You can probably tell that I spent much more time on these goggles compared to my phone goggles. I also wanted the design to be functional and ergonomic, so the UI navigation joystick is here and is very easy to use while wearing the goggles. There is a USB port for connecting extra Wi-Fi modules or a memory stick to transfer the DVR. There is also a DC power connector for connecting the goggles to an external power source, such as a LiPo battery, and a power switch. At the bottom here I have two adjustment knobs, one for each eye. They move the lens and display assemblies left and right, so that people with different interpupillary distance, or IPD, can get the two images to line up. The adjustment range is between 58 and 68 mm. Unfortunately, there is no built-in focus adjustment, since with an optics assembly this size, such a mechanism would make the goggles much bigger. But on the plus side, the lenses are swappable, so it's possible to change the lens to one with a different focal length. I made my goggles compatible with generic 40mm Fresnel lenses from AliExpress, as well as these lenses designed for phone VR headsets. The Fresnel lenses I am using now have a focal length of 50mm, since I found this works well for me. And yes, these are headphone pads. Because they go all the way around each eye, they form a very good light seal, and there is no light leaking in around the nose, like in the VR02 or my phone goggles. My first idea for the electronics was to use the HDMI driver board that can be bought from AliExpress together with the displays. I was going to design my own board that would have an HDMI connector which would plug into the driver board and drive the displays. I wanted my PCB to be based on the Radxa CM3, which is a compute module that has the same RK3566 processor as the Radxa 03W. This way I could make use of the existing OpenIPC SBC and Ruby FPV VRX software implementations, which already exist for the Radxa 03W. But then I realized something. The AliExpress driver board is based around a single Toshiba chip, which can be bought for just $8. Why not include all of the driver board's functionality on my PCB as well? But then I realized that this Toshiba chip is in fact an HDMI to MIPI DSI converter with two 4-lane DSI outputs. And the Radxa CM3 has two 4-lane DSI outputs. Why not give up on the Toshiba chip entirely and drive the display straight from the compute module? So this is what I did. Here is the first prototype of my goggles PCB, which was manufactured for me by Eisler, a German-based company. It was my first time ordering from them, and I am not disappointed. I ordered the boards with a gold-plated INIG finish, and they turned out beautifully. The PCB is essentially a carrier board for the Radxa CM3, with space for mounting two BL-M8212EU2 Wi-Fi modules for receiving the video signal. The board also has connectors for the display ribbon cables and power supplies for the LCD panels and the backlight. As you can see, I made some mistakes in the first version, which I needed to fix with wires to make it work. But I will fix it properly when I design a new PCB. From a hardware perspective, connecting the displays directly via MIPI DSI was much simpler than using an HDMI converter. However, it was an entirely different story on the software side. MIPI DSI is a lower level protocol than HDMI, and the CM3 has no way of detecting what resolution, frame rate, and data format the display needs. In fact, it can't even detect if a display is connected at all. This means I had to write something called a device tree overlay, which is a file that tells Linux in the CM3 what display is connected, what's the resolution, frame rate, and data format, and how to drive the backlight. Since I was very new to this, figuring this out took me a lot of time. I ended up testing 75 versions of my device tree overlay before I arrived at a version that worked perfectly. But the overlay was only half of the job, and I mean that literally. The image appeared, but only on one display. The problem was that both Ruby FPV and Pixel Pilot RK, which is the software that runs on the OpenIPC SBC GS system, are hard-coded to use a single HDMI display. This is understandable, since they are both written for a Radxa 03W, which doesn't have any physical display connectors other than the single HDMI port. Long story short, I had to modify the source code of either Ruby FPV or Pixel Pilot RK to get the video to appear on both displays, and I chose to modify Ruby. At this stage, neither my PCB design nor my 3D design are fully finalized. In fact, the PCB is only the first version and has some bugs. But I really wanted to do some flight tests, since I've been working on this project for 6 months and I wanted to have something working. So I fixed the hardware bugs by cutting some PCB traces and adding some wires, and I was able to build a working prototype. You can probably tell I designed the PCB for 2 of these Wi-Fi modules, but with the bugs I was only able to get one working. For the final version of the goggles, I wanted to have 2 Wi-Fi modules and 4 antennas, with the other 2 antennas symmetrically at the bottom here, a bit like in some DJI goggles. My plan now is to do a lot of testing of these goggles, to find out everything I can about any hardware bugs that need fixing or improvements that need to be made. After that, I will design the next iteration, which will hopefully be much more refined. But I don't know when this will happen, since after working 6 months on this single project, I feel like I need a break to do something different. In the meantime, please let me know what you think in the comments. Thank you for watching and I will see you next time.